Hello guys, so today we will see how to find out the middle element in a linked list using Floyd's algorithm. So for that I took two linked lists. So the first linked list contains even number of nodes and the second linked list contains odd number of nodes. So for this Floyd's algorithm, or to find out the middle element in a linked list, I'm just considering two pointers. I'm naming these two pointers as slow pointer and then fast pointer. So I'm going to consider two pointers. So here I'm going to draw slow pointer and then here fast pointer. So here the slow pointer goes by one hop. Slow pointer goes by one hop and the fast pointer goes by two hop. And then again the slow pointer goes by one hop. We have to do this one. We have to repeat this one till it reaches the null or last node. Okay, again this fast pointer goes by two hop. Again the slow pointer goes by one hop and then the fast pointer goes by two hop. When the fast pointer reaches null, we have to stop, we have to exit that loop and check where the slow pointer is. So here the slow pointer is at number 4. Here the slow pointer is at number 4. So here 4 is the middle point. So here in this one, in the first linked list, 4 is the middle point. So another one more important thing is, if the linked list contains even number of nodes, then the fast pointer reaches null. And then if the linked list contains odd number of nodes, then it reaches the last node. So we will check it again. So here I'm going to take slow pointer here and then fast pointer here. So slow pointer goes by one hop and then the fast pointer goes by two hop. Again the slow pointer goes by one hop. Again the fast pointer goes by two hop. So we have to stop it here because next there is no node next to 5. So if you see here in this two linked list, if it is even number of nodes, then it reaches null, fast pointer reaches null. If it contains odd number of nodes, then the fast pointer reaches the last node. So before that, so in the first one, middle element is 4 in the first linked list, and then in the second linked list, middle element is 3. So I'm marking like this, or otherwise I'm going to use somewhat dark theme. Okay, so 3 is the middle element. Okay, so next we will see how to do this one, how to implement this part in code. So the very important thing is in this one is, if it contains even number of nodes, then it reaches null, fast pointer reaches null. If the linked list contains odd number of nodes, then the fast pointer reaches 5. So how to implement this in code, we will see next. Hello guys, so now we will see how to implement, that is how to find out the middle element in code. So here I created one simple class called linked list problems, because now we are entering into the problems in linked list. So and then I created a simple main method, and as usual I created an empty method which returns null. Okay, so first thing what I'm going to do is, already we created a linked list class. So this is the linked list class I'm showing you. So this is a linked list class which contains how to print the elements, how to insert the element at head and tail, and how to delete it. So if you want to see how to do all those things, you can check my previous videos. So now we will see how to find out the middle element. So I'm going to make use of the linked list which I created already. So I'm using the already existing linked list which I created, or which we created already. Yeah. So now I'm going to do insert at head. So I already created that method. If you want to see, you can check my previous videos. Okay. So I'm going to enter a data 1. First I'm going to take odd number of elements. So 1 and 5. So I'm going to type it like 2, 3, 4, and 3. First I'm going to take odd number of elements. So I'm just commenting this line. So I did insertion, and then I'm going to print this one, list.print of list. So till now I am showing you how it works. So okay, I did insertion at head, so I'm getting like this. So I have to do it insertion by tail so that it will be easy for you to understand. So insertion at tail. Now I'm executing what I'm getting. So I'm getting 1, 2, 3, 4 and 5. So now I'm having one linked list which contains odd number of nodes. And then I'm going to call this method get mid element linked list as a parameter. So now I'm coming to this method get mid element. So what is first of all needed for this one? So we have 2 pointers we already saw in the diagram. So we need 2 pointers, slow pointer and the fast pointer. So both are at the head. So I'm going to create 2 pointers, slow pointer which is at head. So list dot head, and then the fast pointer which is also at list dot head. Okay, so this is the first step. So what is the second step? So we already saw if the linked list contains an even number of nodes, then the fast pointer reaches null. So we have to check one condition like fast not equal to null, and then we saw the condition like if the linked list contains odd number of elements, then fast dot next not equal to null. So what it means here, fast dot next not equal to null. So if it is odd, if the linked list contains odd number of elements, then it reaches the last node. If it is even, so I am just writing it again here. So if it is even, so for example I am taking 1, 2, 3, 4, 5 and then 6. So if it contains even number of nodes, then the fast pointer reaches directly null. Then the fast pointer directly reaches null. If it is odd number of, if the linked list contains odd number of nodes, 3, 4 and then 5, then here in this case the fast pointer reaches 5. So it reaches 5. So I am giving the condition like fast dot next equal to null. But in even it reaches directly null. So I am going to check fast not equal to null. So I have to go till fast reaches null and then fast dot next reaches null. So how to write this condition? I am going to make one while loop. In that I am going to check fast not equal to null. So fast not equal to null. So what it means? Fast not equal to null means it already reached, it contains even number of elements, so it already reached the end of the linked list. So second condition is fast dot next not equal to null. So what this condition means, fast dot next not equal to null, a linked list contains odd number of elements and it reached the last element. It doesn't reach null, but it reached the last node. So that's why we are making these two conditions. So this loop has to execute till the fast not equal to null and the fast dot next not equal to null. So here we know that slow goes by one hop. So one hop, it jumps one step. So slow equal to slow dot next step. And then we know that fast goes by two hop, which means that fast jump by 2 steps. So I'm going to make fast equal to fast dot next dot next. So this is what, so simply when the fast reaches null or fast dot next node is null, then the loop exits and then I'm going to return here slow node. So it is very simple to see, right? But the logic is very important here. Okay, so I am going to explain it again. I am repeating it again. So we already saw the slow and fast. These 2 pointers are at head for the first time, and then we have to check for both conditions. If the linked list contains even, also it has to work. If the linked list contains odd number of nodes, then also it has to work. So we already saw if the linked list contains even number of nodes, then the fast pointer reaches null. If the linked list contains odd number of nodes, then the fast pointer reaches the last node. So that's why I'm making 2 conditions here. If the fast not equal to null, so this loop has to execute till fast not equal to null and then fast dot next not equal to null. So here it is like I'm checking this condition for both even and then odd number of elements. Okay, so this condition, why I'm repeating again and again, is we will use it in the future for so many problems. That's why I'm keep on repeating this condition. Okay, So here I returned slow pointer. So here I'm going to assign this as new node mid equal to this one, and I'm going to print it here. So I'm printing it like, hey, I found middle element. I'm going to print this data, okay, because a node contains data and the pointer to the next element. So I'm just printing the data. So I'm going to save it and I'm going to execute it. Yeah, so if you see here, we have inserted all those things. So it contains odd number of elements. So it contains odd number of elements. So the middle element is 3. So here the middle element is 3. The slow pointer stops at 3. So what if it contains even number of elements? So I'm saving it here. Again, I'm going to execute it. So here if you see, it reaches 3. Something happened. Yeah. This one alone is at head. So I'm changing it. Yeah. So now we are seeing, so the middle element is 4. So we already saw if the linked list contains even number of elements, then it has 2 middle nodes. Then we have to take the second middle element as the mid element. I think you people can able to understand me. So I will just repeat it again. So if the linked list contains even number of elements, then we have 2 middle elements. So here you are seeing 1, 2, 3, 4, 5, 6. So 3, 4, if you consider 3, 4 as middle element, then here we have 1 and 2, and the other side we have 5 and 6. But we have to consider the second middle element as the middle element. Okay. So this is how it works. So in the next videos, we will see the linked list problems. There are so many problems like loop detection and all. So we will see all those things in next video.